So, hello everyone. My name is Fabio Viggiani. I work at TrueSec. I am a penetration tester. So I attack web applications and different types of systems as my daily job. And I also have sessions at conferences like this one, where I try to raise the awareness of how things can go bad from a developer's perspective, and why we find certain types of vulnerabilities. And we do this on several types of different types of environments. Can be sometimes a single web application, can be an entire infrastructure of a certain customer or any type of organization, really. And as penetration testers, it's important to focus on web, on exposed web applications to the internet. Because if you look at how modern attacks take place nowadays, very often they start with hacking an external web application that is facing the internet, and that's how the attackers got the initial foothold in the environment. And then they start escalating and try to achieve whatever their goal is, which often is compromising some kind of internal resource, internal servers, or whatever they're after. So most of my sessions are related to try to understand how it is possible that still nowadays we have vulnerabilities like cross-site scripting and SQL injections that have been around for decades, literally, and we still find them very often during our penetration tests. Well, there are different aspects and reasons why we still see them. You can check my session last year at Øredev. But this time I want to talk about something slightly different. I want to talk about a vulnerability called XXE, or XML External Entity attacks. So why am I going to talk about it? Well, it's a common vulnerability, but it's not in the OWASP top 10. How many of you know what OWASP is? Awesome. We're prepared. Good. So OWASP, Open Web Application Security Project, it's a non-profit organization focusing on web security, and they maintain this OWASP top 10 with top 10 most common web vulnerabilities. And I get the question sometimes, what comes after the OWASP top 10? Isn't that enough if I know all of them? Well, it's great, and you really should know all of the OWASP top 10. But that's not all. There are still common vulnerabilities that we find a lot that are often just ignored just because they're not in the most well-known vulnerabilities. So I'm going to try to explore that, and we'll see how this works, and we'll see how it can be bad and why and how bad it can be, really. So how far we can go from an attacker's perspective. And I'll show a couple of tricks to get some more out of this type of attacks. Because sometimes people think, oh, it's not that bad. But I'll show you that it can be very bad. So what is it? How many of you have heard of XXE? A few. Good. So how does it work? Well, it's an attack that targets applications that are parsing XML data in some way. And the parser used to parse that data is not configured properly from a security perspective. So basically, any application that parses XML is potentially vulnerable to this type of attack. And well, we have a lot of XML around nowadays. Web services or directly from clients to talk to servers. A couple of real-world examples of organizations vulnerable to XXE attacks. This is Google, just a few months ago. They have this feature for developers called a Google Toolbar API, which allows developers to define their own buttons for the toolbar. And they are defined using XML, which is processed by Google's production servers. So that was vulnerable to XXE, and the attacker could extract files from from the web servers. Another example is Runkeeper, common web application for tracking your trainings and stuff like that. And you can upload to their site GPX files, which are just a set of coordinates and other information, and that's formatted in XML. So that had the same kind of problem. So improperly configured XML parser. We're going to see exactly what the problem is. So this is just a couple of examples. And I'm sure you've seen a lot of XML around, so you can imagine how many applications can potentially be vulnerable. So we need to go through some boring part before we get to the actual fun part. I'll try to make it as painless as possible. But there are a couple of things we need to understand to be on the same page, and then we understand how the attack works. Sorry. So XML. Everybody knows XML. We use it to structure data in some way, and it helps us to store data and send it between different platforms. And it looks like that. A DTD, a document type definition, will basically define the building blocks of an XML document. So it will define the structure of the document. It can contain different type of objects that we will see soon. And it can be something that is part of the document itself, or it can be an external document type definition, external to the actual XML file. Elements. Elements are, well, the different parts of the XML document. They are defined, they can be defined inside the DTD, inside the document type definition. So let's see an example. Let's take this one on the left. We have the yellow part after this doc type word. That's the DTD, that's the document type definition. So here we are defining some elements. For example, we have people list, we have a person, a name, and so on, and a certain type. And after that, we have the actual XML document, which uses the element defined in the DTD. And this can be in line as part of the document itself, like the example on the left. If you take the one on the right, we are referencing to a DTD that is on a different file, on this example.dtd. So we are referencing to an external DTD. So far, nothing strange, right? Good. Now, the interesting part for the attack, entities. Entities are similar to macros. You can think of them as variables that sometimes can be complex variables in some way. There are several different types of combinations. They're mainly divided in internal and external. So internal is basically just a definition of a text. So like the example here, the author, that's just text assigned to an entity called author, and we can print it out like this in the document with the ampersand. External entities are what we're actually interested in now. And in particular, we are interested in system external entities, which are referenced to by using URIs. So if you take the example down here, we're referencing to an entity which is somewhere else, and we use the URI to point to it. So that's an external reference. So how does the attack work? Well, the idea is the attacker is able to define an inline DTD together with the XML data that is sent to the server. If we can do that, maybe we're also able to define our own entities and our own external entities, providing whatever URI we want. So if we can do that, then we can do many things with it. We can do local file inclusion attacks, so we can trigger the XML parser to include potentially any file on the system where the XML parser is running. Or we can trigger the server to make requests to arbitrary resources because we can specify URI. So that can be another server on any port, which means we can do internal scans, or we can do SMB relay attacks, and many other things. And also, well, the limitations you have will depend on how the server is configured and what type of framework you're using and so on. But we'll see a few examples. So now, finally, demo time. Let's see. I have an application here, a very simple one, kind of useless too. But the idea is that the client is, at some point, using XML to talk to the server. All right, so I have a page where I can view some logs. And then I have another page where I can test my logs. So if I click any cell on this table, then I go back on the page and I'll see, oh, this button has been clicked. All right, pretty useless, all right? But whatever, it's just anything sending XML to anything. So this is just a simple example. So I want to understand how exactly that call is made, because I don't really see it from my browser. So I'm going to use a local proxy, HTTP proxy, on my attacker machine. I'm going to use Burp Suite. It's local proxy. How many of you know about Burp Suite or Fiddler? Same thing, pretty much. Good. So this will basically intercept all the requests and response between my browser and the remote server, allowing me to tweak them on the way. So I'm just going to set up my browser to use the proxy, Burp Suite. And I'm going to try to do that again, clicking a cell. Now I can see that the browser in the background is making a post request to a certain page, sending some XML data. Let's see if I can make this more readable. It will look like that. So I'm just sending some data that will then be printed out as a log. So I can take this request and just replay it several times. So I'm going to send it to a module called repeater. Now I can change some parts of the request and send it again and check the response. So for example, just to try if this actually works the way I'm understanding it now, I'm just going to try to change something here. I'm going to write test as the data part of the XML that I'm sending. The server will respond with an OK. Then I go back, I refresh my logs page, and I get test here. So this confirms that, OK, it's working like this. I have some kind of AJAX or background request sending XML, and that's being printed out here. Right? So it's XML. So my first thought is, can I do an XXE attack? Maybe. How do we verify that? We try to do it. So can I send this one? So remember the slides we saw before? You have a doc type for starting the D2D, the document type definition. Then you will define your elements. This is just elements to be compliant to what the application is expecting. So you have application and data so that the application doesn't complain about what needs to be defined in the document. And then I'm going to try to add an entity. We're going to start with the internal entity. We're going to call it XXE, and will be some static text. And I will print it out here as part of the data. Right? This is just exactly the same thing without new lines. Ah, come on. And I'm going to paste it here. Click Go. The application says OK again. I go back on my page, refresh. Now I have my text here. OK, so I know I can specify arbitrary entities. Now, of course, writing static text is boring. We want to actually retrieve some kind of resources. What can we start with? we can start with local files on that system. So something like this. Instead of static tags, I'm going to reference an external entity. And I'm going to specify a file on that system. The parser will try to resolve this and fetch the content and put it as the value of this entity, which I then print out here. OK? So once again, this is the same thing without new lines. I'm going to paste it in here. Now the application says, sorry, this didn't work. I can't find file C test. Well, that's great, because at least it tried. Right? So it tried to resolve the external entity. So now it's just a matter of finding a file. This is a Windows system. How do I confirm that I can read files? Well, I need to find a file that is on any Windows system, or most of them. We have the win.ini. That's a file in the C Windows folder for some system boot information. It's not in every version of Windows, but in most. So we can try that. Like this. So exactly the same thing. Hit go. Now we got an OK. So that file was found. And the content was put in here. So let's try to refresh the page. Now our data is actually the content of that file. So we are reading files from that system. Right? Which can be bad enough. But it can go much worse. Because we have several limitations here. The content of the file we're retrieving, if it contains any character that will break the XML, then it won't be parsed correctly. Because that will still be substitute to the entity itself. Right? So if that breaks the XML, then we can't retrieve the file. But we can try to get around that. But let's try it first. See what happens. For example, from a Windows system running IIS, what kind of file would I want to read? Password file. Any file containing passwords, really. Any file containing potentially passwords. Like what? Like configuration files. For example, configuration files for a web application might contain a connection string to a database, for example. Maybe with the clear text password in it. So we access the web.config in the default folder if that's how the server is configured. Maybe the file is there. We can try. So we send it. Paste and go. We get an error that says the configuration element is not declared. What's the configuration element? That's part of the content of the web.config. So we are actually reading the content. But, well, the content of the web.config is XML. It's not going to be compatible with whatever we're defining here. So we need to go around it somehow. We need to get the parser to ignore the XML syntax of whatever file we are retrieving. How do we do that? Yeah, or something like that. Can we have a C block, for example? C data block? Like that? Yes? That's a block that basically tells the parser not to interpret that data as XML. So how do we have that in our entity? could do something like this. We define an entity called start. It's an internal static entity with the beginning of the CData block. Then the file entity will be the actual content of the file. And then the end will be the end of the CData block. And then we just print them in a sequence like that. So the file will be within the C block, a CData block, sorry. That would be great, except it doesn't work. Now the problem has to do with entities defined within the same DTD. You actually have to go and dig a little deeper in how the XML standard is defined to try to figure out why this wouldn't work. But we can't do it like that. But we can make it work in another way. So encode it. Yes, that's one way of doing it. We could, for example, base64 encoded or some type of encoding, which kind of removes all the XML part. Yeah, we can do that, but how? I mean, we need to somehow tell this to encode it. What do we use to encode it? Pardon? Yes. Hold that thought. One way we can do it is, well, the reason why we cannot do it like this is because they're all defined in the same DTD. So we can go around it if we define some of this in a different DTD, which could be a sub-DTD. So a DTD reference within this DTD. So something like this. So we have our start. Then we have our file, and then we have our end. Now, note that we are using this % sign here. That defines parameter entities. They're a little bit different. Work pretty much in the same way, but they can be more complex, and they can only be referenced within the DTD itself. So we reference to a different DTD, hosted somewhere else. This is my attacker machine. So it's my own web server as an attacker. This will, in a real attack, this will be an address on the internet where I host my own DTD file, which will contain this. Very simple, just an entity called all, which will print out start, file, and end, which were defined up here, start, file, and end. And we call it here. Then in the data itself, we call the entity defined in the sub-DTD. It's just a trick to go around the fact that it has to be in a different DTD. All right? So if we look at my own web server, I have this combined.dtd. That's what it contains, exactly the same as I just showed you. So this is what we're sending. Now we got an OK. That looks better. We go back and refresh the page. Now we have the web config here. With some usernames and passwords. All right, so we try to go around limitations, because there will be many. Because now we can read files. We can read even XML files. But we are still within the DTD. So if we break the DTD itself, so with a % sign or an ampersand, then it will still break the parsing. Another thing that we are relying on is the fact that the application is printing out the data that we're sending. That's why we can see it. That's not always the case. It's a very fortunate case. very demo-friendly case, but it's not always the case. So how do we go around that? I had a suggestion from down here. Why don't you send it as the parameter in a URL? Which is good thinking, hacking thinking. So can we do it like this? Again, we use the concept of a sub-DTD hosted on our own server. We take the file from whatever file we want to the system and the DTD. Now, this evil.dtd will contain this. Will be basically, just let's skip the details, but basically will be an entity that defines an external reference to my server, once again, passing the file as parameter in a get. So it will work like this. Basically, we have the attacker sending a custom DTD, which will trigger the server to fetch a local file. Then we have a secondary DTD contain the evil.dtd definition, which will basically take the content of that file and trigger the server to make a GET request, passing that file in the parameter back to me as an attacker. Then on this side, I can just wait for it and read it. So let's see if that works. Click Go. Well, I'm getting an error. And well, obviously I do. I'm trying to print the content in some way, right? So this will break. But as long as I trigger this request, I don't really care if the parser breaks after that. So then I can just go back and check the logs on my web server. And what's this? This is exactly the content of the file. So this is the GET that was made by that system, passing this as a parameter. That's the content of the file. Now, it's kind of readable here, so we need to URL decode it. We have a decoder in Burp Suite we can use. Decode as URL. And that's the content of the file. So now we are using a out-of-band channel, if you want to call it like that. Now we're not relying on the fact that the application is printing out data for us. We're just triggering the application to make a request with arbitrary content taken from the file system. Good. So I have access to whatever files the application can access on that system. But I don't want to stop there, because as I mentioned, this can get much worse, depending on what your goals are. So I want to try to break out of this system. This will be a system that is exposing some kind of service, a web application, taking data from the internet. It will most likely be in some kind of DMZ segment. But as I mentioned at the beginning, we can trigger the server to make requests to arbitrary locations. Those locations could be internal servers, right? So let's look at this. This is a typical scenario. We have the vulnerable web server somewhere in the DMZ, which will have possibility to talk to internal servers. And I can trigger that server to make arbitrary requests, which is convenient for an attacker now. So what can I do? Well, it's up to the imagination, really. I can do, for example, internal scans. Can I do that? Port scans, yes, of course. How? Well, I just basically try to reach a certain IP on a certain port. And I will see if that works. Depending on the error I get back or on the time that I get a response, then I know if that service is listening or not. So something like this. So let's try to do it. Take this IP, for example, .2 on port 445. What's that? That's SMB protocol. So Windows network shares. I hit go. And I see that this is taking some time. So now the server is trying to connect to that service, the SMB service on the internal server. And it's probably timing out, because nothing is responding on the other side. Yeah, that's what we get. So unable to connect to remote server. So we know that port is closed on that IP. We can automate this, of course. Take the entire internal IP range for any port. You script this, and you can scan the internal network. Then you know what services to go after through this server. Obviously, we can browse internal web applications, right? We can make the server make GET requests to arbitrary locations. So how do you browse a web application through an XXE? Well, let's say we do all the enumeration of internal services, whatever shares we find, and we found some internal web applications. This one's down here, for example. Right? We do it with the scanning. So I can access it just like this, right? And using the evil DTD, this will send the content to my server through a GET request. What will the content be? That will be the HTTP response from the internal server, right? So let's see how this looks. Well, I get an error, says remote server returning error 404 not found. All right, fair enough. Maybe I don't have the right page. I can keep doing this in an automated fashion for all the open port 80s or 443 or 8080 or whatever that I found. Sometimes I need the host name too, right? But you have access to almost the, well, you have access to files on that system. Whether they're accessible or not by the application running the XML parser will depend on the privileges configured for that identity. But in theory, you can. In some cases, you can try to resolve a name internally. And in the error message, you will get the resolved IP. I've seen that a few times. Now, in this case, if we try to resolve something, we will just get back couldn't connect to the name, for example, but we don't get the resolution of that name. So let's take a shortcut. See, we find an internal name. 40 minutes is quite short to run all these things, so I'm going to take some shortcuts. We find the name. We find the name of internal web server. That will be called internal.TrueSecDemo.com. All right? So we browse there. It's not really browsing, but Now we get that message back. We know that's good. That meant that the GET request went through. So we can go back, check the logs. Now we have a new GET. You can URL decode this. And this will be the HTTP response of the internal application. So now we are in some way browsing internal application through the XXE on this server. It's not very smooth browsing though, right? Requires a couple of steps and read the logs of the server and URL decode. Wouldn't it be nice if we make it transparent for an attacker to do all this? Yes, it would be great. So I wrote a small plugin to a Python proxy. It's a very rudimental state. I mean, I finished it up last night, so don't expect anything fancy. But the idea is, this is just a proxy, local proxy, just like burp, pretty much, where you can write your own plugins. Actually, looks better here. So this just takes a request coming from your browser. Instead of sending that directly to the server, it takes the internal name that you're trying to go into, and it will just point it instead to the vulnerable application, the one that is vulnerable to XXE, and the body will be the XXE attack using your internal reference. Now, when the response comes back, instead of giving that back, it will replace it with the content of the logs from the Apache server. So basically, whatever I've done manually now will be automated in a transparent way. So start the server, sorry, the proxy. Now we set our browser to use that proxy, and then we browse directly to internal.TrueSecDemo.com. And now we're browsing the internal application. We don't have CSS and JavaScript and all that, but we don't need that, right? We can make the proxy better. Again, that's a hack, so it's not can't be done much better. But that's the idea. Now we can browse transparently to whatever this application is doing. And of course, internal applications are much more weak than internet-facing applications, right? So we can find a whole lot of vulnerabilities internally. And we find internal management interfaces for whatever type of device, switches, firewalls, routers, web servers. Well, it's internal. You know how many times we find them? All the time. There will be some interface exposed internally. Sometimes it's properly configured with a strong password. Sometimes it's weakly configured with default password. Sometimes it's configured with no password at all. Sometimes it's an old type of server or service that is vulnerable to something, and nobody really cares that much about making it secure now because it's internal. It's not exposed. But now it is exposed. So for example, on port 8080 on this server is a JBoss interface. Now that's an older JBoss server. It's a 5.1, I think. This one allows to deploy an application through a GET request, basically. You can deploy your own WAR file just by making a GET request to the JMX console to the right page with the right parameters, which will look something like this. So if you make this request on the JMX console, HTML adapter, you pass some parameters. You want to access this service deployment file repository. You want to deploy a file called webshell.war with index.jsp with whatever JSP code you want to put here. what will the JSP code do? It will run code in the system. It will run server-side code. Right? Can we do that? It's what we call a web shell. A simple one looks like this in Java. We take a parameter. We use it to run a command on the system. We output the result. That simple. So I'm going to skip all the tricks you need to do to make this work. There is basically just some encoding stuff that you need to take care of. So I'm going to scroll down all the way. It will look like this. It's basically the same as you've just seen, just merged together and do some double URL encoding. So if this works, under here I will have a web shell taking a parameter called cmd, where you can write your commands, who am I, for example. Now nothing is there. You will get a 404 from the XML parser. If we click this, now this might have worked. So we go back, refresh this page. Now we have a shell. Now we're running commands on the internal JBoss server that is somewhere here through an XXE, transparently through a local proxy on my machine. So a combination of different techniques made this XML parsing really bad, right? And just to summarize, we've seen how to include local files, how to access different types of resources, how to make internal scans and exploit internal vulnerabilities. So they will be much more common than externally. And there are more attacks we can do. We can do denial of service, of course. We can do SMB relay. And in some cases, depending on how the server is configured, we can even get remote code execution directly. But why was it possible? It's simple. We allowed the user to write inline DTDs with custom external entities. That's all it took. So how do we fix it? Well, that's very simple, too. We just don't allow that. Do we really want the user to be able to route their own DTD inline when they send XML data? Probably not. So you just disallow that. You can configure your parser to use a static local DTD on your system and just reject whatever is defined inline by the user. And just as a reference, you will be vulnerable if these 4 things apply. If you parse XML, if you allow inline DTDs and custom entity references, if your parser accepts that and validates the DTD, and the external entities are resolved, then you're vulnerable. So what's up with that? Why do we see it so often? Well, there are some libraries and frameworks that have that enabled by default. So you actually have to explicitly disable that. More modern web services, they have definitions to disallow this if they go over XML. For example, SOAP 1.2 specifies that this should not be allowed. You can't have DTDs. But that depends on the implementation. Some implementations don't do it really right. Or you can do your custom XML parsing. But in general, I think there is a lack of knowledge. I don't know how many of you knew before this that you can do all that just because of some XML parsing. Some of you maybe knew, but I think many of you didn't. And there are definitely a lot of developers out there that they just don't know about it. So I think it's important to try to talk a little bit outside of that OWASP top 10 that we always talk about, and experiment other things too, and try to take this message out. So that was it for me. Now you can go home and make sure your XML parser doesn't allow inline DTDs. Any questions? This one was .NET. In this case, because I used .NET 4, then I had to enable it manually. So after and excluding 3.5, so from 4 and on, then it's disabled by default. Before that, you have to disable it yourself. I think I'm running out of time. I'm going to be, or, well.
It's fine. Keep talking. I'll supplement stuff.
All right. Yes?
What is the pattern SSL connection between your preset and the backend server? Would this actually work?
Well, that depends if, yeah, I don't see why not. Depends on how the parser will, well, it will be in the context of the application running the parser. So it should work unless you, unless the application doesn't trust the certificate, for example. Yes? That will definitely help in what type of files you can read on the system. But to trigger the application to make connections to other resources, that doesn't really have to do with the privileges of the application itself. Because it will be the parser that, if it's configured to resolve external entities, then the application will make the request. OK. Well, that was that. Thank you for listening.